Good morning, Mr. Christian Janke from Embry-Riddle Aeronautical University.
Good morning also from my side, and thank you very much for the invitation. Microphone is okay this way? Excellent. I will start the day with a conceptual overview. So consider this as a status analysis, gap analysis, and outlook in a particular field that has been used in Rotorcraft for quite some time, and I will apply that to E-VTOL. So this is the slide change. Yes, I'm Chris Janke, as said, from Embry-Riddle Aeronautical University, and I prepared this conceptual presentation together with a colleague, Dr. Erich Beckhofer from the United States. He and we are doing research in Rotorcraft safety, but also in particular in electrical drivetrain safety and HUMS for EVTOL. That's why I prepared this presentation in this way. And I myself have been living in both worlds. I have been a helicopter pilot in the German Army for quite some time. And the last 10, 12 years I spent in the, so to say, drone world, building drones, teaching. I have a program that I'm instructing at Embry-Riddle that is particularly considering unmanned aircraft systems and safety as well, of course. And that is the conceptual overview. So many of you know, because of your background, of course, what health and utilization monitoring system means for helicopters. This is a well-known topic, and it is used to allocate sensor data, monitoring the traditional helicopter, the different parts, gearboxes, rotors, and structure. And in most cases, when I talk to many maintenance operators, it's downloaded post-flight, and then they're pending on the system, there is some kind of assessment. And that can be a very traditional assessment, almost analog, but also going into detail with prognostic algorithms, looking at the degradation of systems, changes, trends, allocations, and that is has been proven that it has been improving the safety for rotorcraft by giving a better situational awareness to maintenance personnel and, of course, preventing catastrophic failures. So much for traditional helicopters. Now let's look and compare a little bit and at a traditional helicopter and a new vertical takeoff and landing system, and think a little bit about not only aspects such as price, weight and size, but also parts and degradation and the general setup and what that means in comparison to many aspects that are related to maintenance. The status quo in eVTOL aviation, that is my personal perception, maybe more a little bit in the continental United States, but also in Europe, is that there are a number of startups building eVTOLs, and this number is still growing. And we see a lot of capitals and investor expectations. I'm sure that many of you have heard of the unicorns, so not publicly listed companies that are having mock-ups, prototypes, maybe only a computer simulation. And there are different technology readiness levels here, and definitely some of them are very capable. We have seen flying platforms, for example, in China, the EHang system, and you can really say that the technical capabilities of these platforms outpace the regulatory framework. Hence, there is no comprehensive certification or airworthiness framework. I'm very much appreciating what EASA has been doing in comparison to other national systems, in comparison to the VTOL special opinion, for example. So that is a good way forward, but still there is no type certificate or airworthiness framework, CAMO, all that when it comes to the certification, and also no legal basis for autonomous operations. Why autonomous operations? Because if we look at the business model for an eVTOL, it is very clear that the influx of capital was possible because investors are not counting on pilots. The revenue and the profit generated by an eVTOL only will have a very profitable curve if there are only passengers. And of course, everybody is aware that we need to start with piloted vehicles, so there will be maybe also a pilot training, and a lot of education companies, CAE for example, and also my university, Embry-Riddle, are working on pilot training for eVTOLs, and that is also very important, but that will be only a transitional phase, because at the end there must be a autonomous platform, and of course there will be platforms for cargo as well. And the push to automation, later also to autonomy, makes all the inhabitants passengers. So there will be no side stick, only an iPad. And this is something that is of course very new to regulators, to insurers, and also to passengers. But these autonomy will make autonomous fleet and operations possible, and increasing profitability and the revenue passenger mile that can be created with a autonomous platform. And of course these systems need to be highly connected and electronic conspicuous. But what makes, and think back of the two slides before, the volocopter and the Eurocopter, what makes eVTOL different? So many of those points are common sense, right? So there are much less parts. It is an interesting and maybe good analogy to talk about electric vehicles, cars, and a traditional combustion engine. The factor might be the same, less parts. So we have especially less moving parts, which is has an extreme impact on maintenance. There is a highly automated flight stabilization. Really, this is the case not only for the whole system, but also the different components. They are highly stabilized, and most of these platforms are battery electric or hybrid. And when I say hybrid here, I mean hybrid propulsion, meaning fuel cell, buffer battery, and electric propulsion. And this design, and I'm sure maybe some eVTOL manufacturers might disagree, but the configuration and the topology of an eVTOL and a drone is very much the same, with the flight controller, electronic speed controllers, the motors, and the flight logs are very similar. So there is a lot of overlap, and that's why also the configuration are very much remembering on that, like multicopter, fixed wing, or transition hybrid, meaning tilt rotor or tilt wing. There are multiple engines and drivetrains, so not only one or two maybe. There are very, very much of them. As you see, I think the volocopter has 18. And in general, you can really say, in comparison to the range that a helicopter has, that the battery limits the flight performance. So we have currently physical limitations, the gravimetric energy density, for example, kilowatt hour per kilogram or per volume, that is not growing as many of the eVTOL companies would like it to see to grow, but this is definitely, that's why a limiting factor, and might be also not so well known in the first place, but in comparison to a helicopter, the eVTOL is completely dry, so there are no liquids and nothing that is compared to that as into a helicopter. So what can we now do in HUMS for an eVTOL? The components of interest are very clear: the flight controller, the batteries, propellers, motors, the payload, and of course the data link. Data link is in maybe something that first comes to mind when you think of a remotely piloted system, but as I said, they are piloted by a pilot, but when they come more autonomous, there is always a supervisory link, of course. So they need to be integrated into airspace, so there is telemetry that is transmitted, and not only telemetry about the position, but also, of course, the health. So it is possible with eVTOL much better, due to the connectivity, to have an in-flight HUMS in real time, looking at the status of the battery, the motors, and for that you need parameters of interest, and those can be vibration, temperature, voltage, frequency, noise, the current, and many, many more. So these sensors are also in a factor much, much higher deployed on an eVTOL than they are on a traditional helicopter. As I said, there is possibility for real-time in-flight HUMS for eVTOL due to the connectivity, ground-based. It can also be via satellite in cases where you don't have a good ground connection, and you could use that on board, but also in the cloud to process these data and to look at it. And as in every field in the world economy where you create data, you can use artificial intelligence and machine learning to do pattern recognition or anomaly detection and look for the degradation of systems. And that will be a very interesting process. This is the research that I'm doing just since almost a year, and I'm barely getting any data from manufacturers, but I will talk about this also. So what can be the benefits of HUMS for eVTOL? And this is a screenshot from a system that has been developed by my colleague Eric Beckhofer in the United States, the GPMS Foresight system. This can be used to allocate these data and to go into different details, look at trends, having just a operator and supervisor dashboard to look at the data. It is clear that you can reduce unscheduled maintenance. This is also happening in eVTOL, unscheduled maintenance, and there are lower maintenance and operations cost. And of course, it is clear that the sensors that are put on the eVTOL cannot increase the footprint in weight and size as well. It's very important to keep that in mind. I would like to take one component because it's really the most critical part when it comes to the flight envelope, which is the battery. There is not only when it comes to the rare materials producing batteries, but also for the controllers, for the people who can handle batteries right, a huge challenge right now to find personnel and to look at these engineering aspects of the batteries in eVTOLs, because many of the people looking at batteries as an electric propulsion are working in automotive currently and always being poached by higher salaries, for example, from an eVTOL company. We have seen that in the US a lot. So how many batteries do you what kind of batteries do you use? There is an interesting difference in power draw in takeoff mode than in continuous flight. That is a huge challenge for the battery design. If you have cruising flight, you have much less power draw. If you are using a fixed wing, for example, and that needs to be also reflected in the battery design. So how much how much redundancy do you need? In batteries can fail, battery controllers can fail. There is not much available data currently about the battery life development. You can not only use the battery data that you get from the electrical vehicles on the ground, because it's a different setup most of the time and a different power draw, but this is really an interesting factor, the degradation of the battery, capacity degradation, and compare that to a gasoline tank from a helicopter that is always the same amount of liters, and you can count on that for your flight time. In battery life, it is a little bit different, so you need to be able to predict the life of the battery capacity, how much kilowatt hours that you have for a certain flight time. Not considering the safety aspects of having a reserve, getting to one landing pad to another, or weather. So all these things that later come in when we look at traditional manned aviation. So there's definitely a limiting factor, the batteries, due to many, many reasons. And one of them is also the battery degradation. So there are many challenges. I'm not saying any names here because most of these data are under NDA, but there are definitely thermal challenges for large electric motor layouts when they are in maximum power draw and takeoff mode. This is a big problem for the general layout, and there is no historical data about fatigue and degradation. Of course, there are not many moving parts, but there is fatigue as well. There are problems in even in a brushless motor, there can be a problem after some time. So this needs to be looked at. And currently there is only, I would say, guesswork when you look at the maintenance intervals. So the condition monitoring has no probability because of no historical data. And to look at wear and tear and fatigue, you need to estimate the certain degradation. That means that mishaps will happen, and hopefully these mishaps will be without casualties. The problem is that currently we have a risk culture that will influence that perception and growth. And we have now been, and that is a good thing, not very used to the number of casualties, to risk being considered in a way that is very risk averse, so not accepting a lot of risk, trying to make everything very, very safe. And that is a good thing when you look at maybe traffic or medicine and healthcare. But if you try to develop a new platform and bring that into market, that can be a problem because there will be a different perception to it. And that perception means For example, just look at something that is new like EVTOLs, and there will be accidents, how they will be considered towards helicopter accidents. Just a little analogy to the automotive sector. I'm sure many of you have heard about the famous Tesla accidents, the autopilot, and that has been gone through the media, representing only a very small portion of all casualties on the streets. So in Germany alone, there are 3,000 people killed every year on the streets. In the United States, 35,000 people die on the streets every year. And the majority of the media coverage, of course, was about the Tesla accidents and the autopilot problem. So there's a difference in the risk perception. That can be a problem. And I brought an example to be more clear about it, talking about the early starts of urban air mobility. There has actually been an urban air mobility example in New York City where a helicopter offered shuttle flights from central New York to airports around. And that went on for quite some time, of course, very expensive, very loud, a lot of noise, and not everyone liked that, but there was then one very famous accident that was, by the way, also created by fatigue, and this helicopter crash then led to the complete end for a very long time of these shuttle flights, urban air mobility in the 70s. So I'm just saying that and bringing this example to really raise awareness that risk perception today can be a problem if you introduce new technology, and you always need to be able to take it away from emotion and be very rational at a risk perception, something that we all have to look at when we try to introduce EVTOL, and that is very important. So another challenge is, or challenges are the regulations. I talked about this a little bit. Currently, if there's an autopilot and there is a fully autonomous platform where maybe the passenger cannot integrate or influence anything that is happening, you need to be sure that everything is very safe, and the mean time between failures in an acceptable level. And that means also that you have to be able to insure it. So nothing that can not be insured will ever fly. So the insurers and also the back insurers will definitely look at this and want to see the numbers, and this is how they will place the premiums. And this can be also becoming an important cost factor, insurance for EVTOLs, even more in autonomous platforms. Currently, and that is the same for electric vehicles, autonomous cars on the ground. Who is to be blamed if there is a software problem when there is an accident? Again, cannot be human factors then, because the human was not in the chain. But again, we remember human factors as a cause for aviation mishaps is, I think, around like 80%. But if you bring that out of the evaluation, you have at least or definitely a higher level of safety, definitely, and that needs to be into consideration and from a rational point of view. So there must be data and also development for autonomous platforms looking at the liability. That is very important. And because we have high connected systems and platforms, we need to include cybersecurity aspects. I'm not seeing that currently when I hear press statements or the different releases from these companies are not looking to, from my perspective, enough into cybersecurity, because again, this can be a huge problem if there is a malicious intent to do something. There can be some attack vectors that needs to be protected. Potentials for the future, and I'm citing here a white paper from Lufthansa Technik that has been looking into health condition monitoring quite some time ago, looking of course only into drones, but some of those data can be overtaken. Standardization of flight log data, that is very important. So we have of course the same components, but the way we measure them and we get the parameters right, that is very important. And I'm just calling out, if some of you are producing EVTOL, try to collaborate and standardize flight log data, because that is the basis of everything. Also standardization of links for data transmission, and in order to be able to deploy that, we need of course the right infrastructure for real-time connectivity, starting with basic airspace integration technologies such as ADSB or Network Remote ID, but also for better data links using other means and frequencies. Yeah, and as I said, it's possible to do real-time diagnosis solutions integrated into the UTM environment. Many people, when they think about U-Space or UTM, only think about, and that is mostly correct, the telemetry and position data for airspace integration and detect and avoid. But if you add some diagnostic data to the bandwidth, that can be a problem if the portion of the bandwidth is too small. So we need to look at this as well. Actions needed. So I'm just saying what I think needs to be done without having any solution, but I hope this small presentation will lead the way and maybe come to a situation where we can collaborate on that. Currently, it's the situation that we have a very high level of safety in manned aviation, rotorcraft, fixed wing, commercial, business aviation, general aviation, maybe not general aviation comparison to commercial, but when it comes to the safety management systems, flight data monitoring and HUMS, this is the level that we accept, and this is the way we conduct business in the aviation sector. This is not always the case in the tech companies that produce eVTOLs, because the majority of the people working there do not come from aviation. And you cannot blame them for that, because they have a different approach. They are not very exposed to the aviation principles. And I think this is needed definitely to have an understanding for people working on those flying platforms, to have safety management knowledge, risk assessment, also just culture, something very special that we developed here in aviation, and that needs to go into the eVTOL economy as well. And that goes not only for manufacturers, but also for operators and MRO providers. So I hope this will get into this. Our university is developing courses right now for non-traditional aviation economies and participants introducing safety management. And we will start to do that next year and hope to see some aspects there. Also, yeah, education, that is something that affects me as well as an academic, as a program chair. We need to develop and transform education, and both vocational and academic. So I can talk as an academic. I have a program, Bachelor of Science in Unmanned Systems Applications, around 600 students right now. The number is growing. We have a Master of Science in Unmanned Systems. We try to integrate on a very fast pace the developments of the different industries, the aspects that are growing there, and in vocational training. So the maintenance mechanics and everybody who's working on that, that is a critical aspect where you definitely need to include several fields. And that is almost like a hybrid education. You need to include aeronautical science, maintenance, computer science, and mechatronics. Right now, most of the people who have knowledge in mechatronics work in the automotive industry. So looking at controllers, embedded systems, being able to not only solder, but also to program. That is a very, very special skill set. And I anticipate an extreme demand for these persons in the next 5 years. And currently we don't have enough of them because if you learn at a traditional university or a maintenance organization and getting trained in aviation and aeronautics, you get not said what is a kV rating of an electric motor or what is a PID. So that needs to change. We need to integrate those programs and bring them together, and also really bring the technology in the curriculum, both on vocational training and academic. And that is something also that is really near me. Start with STEM education. I'm also in schools. I'm also a STEM coach for a small initiative or larger initiative that is called Drone Masters Academy. They are doing STEM training with little drones in schools, not only bringing the knowledge to the young people, but also sparking interest and inspiration for that field. And that is very, very important. Actions needed 3. Further research and data, of course. For me, coming from research and development, that is very important to have access to the data and to be able to compare that. And there need to be extensive testing for fatigue, battery life, and system safety. We cannot simulate everything. We need to go out and let the platforms fly. And I hope that the eVTOLs will have some secret places where those platforms fly day and night, until they have at least 10 to the minus or 10 to the 5 flight hours, and they can really say that this is happening and not only simulate mean time between failures. And for that, we need industry-wide collaboration and prevent parallel structures. and analysis, because many of those platforms are, or these companies are working in their own field, not sharing information, and that is not good. And that is my most important point as a message to eVTOL economy. Safety data cannot be intellectual property. That is very important. So collaboration is needed for industry protection and risk reduction. It is very, very important that we come together and bring the data and the flight logs together and really see how these systems will develop, and to learn from that. Is it going to be an anonymized platform or system, or in a shared space? I don't know, but it's definitely necessary, because right now there's a lot of redundant work and research being done in all these data. And that is my last slide, just a short look at the eVTOL supply chain. As you see, some of those companies also work in automotive, but this here is from Agility Prime, a platform, a concept that has been developed by the United States Air Force, also a very conservative organization looking at eVTOL. And as you see here, these companies, they will make up the majority of those who provide components for eVTOLs in the near future. Yeah, as I said, for the early morning, starting the day, a conceptual overview, looking at the different aspects of HUMS applied to eVTOL. I hope I was able to share my thoughts and also provide an overview and also a message to the eVTOL community. And if you're interested in doing common research or a publication or a certain push forward in collaboration, definitely reach out to me. These are my contact data. I'm based in, even though I work for the American Worldwide University Worldwide Campus based in Germany, we have a campus in Frankfurt am Main where Embry-Riddle brings people together, and I'm very happy to discuss further points with you. And yeah, that is the end of my presentation. Thank you very much for your attention.